This is the last video for section 3.1 in the textbook. So at this point, you should already know how to draw graphs based off of equations in vertex form. So this last video for the section is going to look at how to go the other direction. So the big question for this lesson is, how do we get an equation from a graph? And we are going to be focusing specifically on vertex form here because this isn't really something we're ever going to do in standard form. So thinking in terms of vertex form, our generic version is y equals a times x minus p squared plus q. So to answer this question, to be able to figure out what equation gave me the parabola that we can see on the screen right now, I really need to figure out three things. I need a, p, and q. The question is going to be, how do I figure those out? So first things first, it is a vertex form, and it's called the vertex form for a reason, because if you remember, it's based on the vertex. So our first step is going to be pretty easy. It is going to be to just get our p and our q values from the vertex. So in this particular case, if we look at our graph, our vertex is right here. So we're going to take that point, which is at 3, negative 4, and we're going to plug that in for p and q. So when we do that, we get y equals a, still unknown, x minus p, so that's going to be x minus 3 squared, and then plus q, which in this case is going to be minus 4. So already we're 2/3 of the way there in terms of filling things in. We've got a p, we've got a q. Now we need to get a, and that's going to be a little bit trickier. So to get a, our step 2 here, we're going to go back to our graph, and we're going to pick a different point on the graph. So we can't use the vertex here. We've already used that. But we're going to pick one of the other 2 or 4 points that you might be able to see on your graph, and we're going to work with that. It's up to you which point you're going to pick, but generally I recommend you try to pick points, ideally with easy numbers or things that are close to the vertex, just to make your life a little bit easier. So in this case, if I look at my points and I try to find the one that has the easiest numbers, I'm probably going to pick that point at 1, 4 that we can see on the left. But yeah, we do have some options here. So for me, way up at the top of the screen here, I'm going to be going with this point, the one that I've just highlighted in blue, which is at 1, 4. If you want to use a different point, you're more than welcome to, although for this video, I'd recommend you follow along. So now that we've got this point, 1, 4, we're going to take it and we're going to plug it into our vertex form that we already figured out for x and for y, because points are just x and y values. So we had y equals a times x minus 3 squared minus 4. And so this y value of 4 is going to go in for y, and this x value of 1 is going to go in for x. So we're just going to plug those in now. So we've got 4 equals a times 1 minus 3 squared minus 4. And if you look closely at that, you'll hopefully notice that there's actually only one thing at this point that we don't know. It's just the a. We've got everything else taken care of. It's just a bunch of numbers. So our final step in this process, step 3, we're going to take all this, we're going to simplify it as much as we can, and then we're going to solve for that a value. So at this point, we just need to follow along with some basic operation stuff, some like grade 8, grade 9 solving skills, and we'll see how it does us. So first things first, we've got, well, x minus 3. We can do better than that. So a times negative 2 squared minus 4. Then we can maybe square that negative 2. So that's going to get us 4 equals a times 4 minus 4. And so now, looking at this, a really common mistake people will make will be to combine the 4 and the 4, but that doesn't work. Remember, this 4 on the left, we've got a lot of them. This 4 is attached to an a, so we can't separate it from the a just yet. What we want to do is we want to solve for a. So opposite operations, we want to move the negative 4 to the left side of the equation, and we're going to do that by adding 4 on both sides. So 4 plus 4, that's going to get us 8 on the left, and on the right, we still just have that 4 times a. And then our last thing here is we're going to get rid of the 4 on the right by dividing. So we divide both sides by 4, and a is going to be 2. So that's all done. Last step is an easy one. It's just take all that and put it all together. So we need to actually answer the question and figure out what the equation is. So we end up with y equals 2, and then x minus 3 squared minus 4. Right, so we've taken our vertex, we've taken our a value, we've put it all together, and we've got ourselves an equation. Looks good. So with that in mind, let's try a couple more. So we've got 2 graphs here. We're going to start with the one on the left, the red graph. So go ahead and pause me right now, try the red one on your own, come back once you're done, see how it went, and then you can try the blue one after that. All right, so if we're looking at the red graph here, remember our vertex form is y equals a times x minus p squared plus q. If we're looking at the red one, our vertex is at negative 6, 7. And our point, well, we've got some options. I'm going to go with the point over here at negative 5, 4. You don't have to write all this stuff down every single time. I'm just doing it to help keep track of things. So, setting things up. To start, I'm just going to plug my vertex in. So that's y equals a times x. Being careful with the negatives, it's going to be x plus 6. So remember, that's x minus negative 6 squared, and then plus 7. Really common mistake when doing this, by the way, is to forget to include the square. So make sure you have that, or else everything's going to go wrong. Now we can plug our point in. So our y value is 4. A is just a. Then we've got negative 5 plus 6 squared plus 7. So far, so good. We could simplify a little bit. So the negative 5 plus 6 is just going to be positive 1. 1 squared is also 1. So that gets me 4 equals 1 times a plus 7. And now we can solve this. And this is a really easy solve. So the only thing we actually need to do is move that 7 to the other side of the equation. So if I subtract 7 on both sides here, on the left, I'm going to end up with negative 3. And on the right, well, 1a is just a. And so our a value is negative 3. And we can kind of get a sense that this looks right in a couple of ways. So if you look at the red graph, first off, it is pointing down, so we do know a should be negative. And second, if you remember the pattern graphing method from the last video, from our vertex, we can see that we're going over 1 and down 3, which fits the pattern and which fits our a value. So that's perfect. So we put it all together and we end up with y equals negative 3 x plus 6 squared plus 7. Awesome. So double check your work, make sure you got that. Pause me again here and try the blue one, and then come back once you're done with that. All right, now looking at the blue one. So jumping straight into things. Our vertex is at positive 5, negative 6. That's this point right here. So we've got y equals a times x minus 5 squared minus 6. lots of points we can use. No strong preferences. I'm going to go with this point right here. It's the smallest numbers, close to 0, but it doesn't really make much of a difference. So my y value is going to be -2. My x value is going to be +1. And now I just need to simplify and solve. So 1 minus 5 is -4. And -4 squared is 16. Okay, I've done all the simplifying I can. Now I need to move some stuff around, so I'm going to add 6 to both sides. -2 plus 6 gets me +4. And I've still got that 16a on the right. And last step, I'm going to divide both sides by 16. So I end up with 4 over 16. And just saving ourselves a step, if we simplify that, so 4 over 16 is going to become 1 over 4, right? We divide the top and the bottom by 4. And so if we put everything together, we've got y equals 1 over 4 x minus 5 squared minus 6. Once again, if we look at our graph, that tracks, right? It's going upwards, so it should be positive, but it's going up really slowly. It's really shallow, which does tell us that a is going to be small, so a small fraction does make sense with what we've got there. And there we are. That's the gist of this. So hopefully that worked out for you. In the next video, we're going to move on and we're going to take a look at standard form and see how that compares.